Enlargement is a transformation that you don't change the shape, but you increase or decrease the size of the object. So the shape is unchanged, but certain things will remain the same, like the angles will be, the corresponding angles will be equal to each other. So when we do an enlargement, we have a center of enlargement, a point like this, and an enlargement factor or scale factor. So that's just comparing the sides. So OA compared to OA prime. So that gives us the scale factor, how much have we increased or decreased by. So two figures are similar if one can be enlarged to be congruent, remember congruent to each other. We get corresponding angles are equal to each other. So this angle ACB is the same as A prime, C prime, B prime. And pairs of corresponding sides are in the same proportion or ratio. And the scale factor can be described as this. Image length, so in this case C prime to B prime, over top of original length, C to B. So that gives us some handy-dandy rules. If the scale factor is between 0 and 1, so it's, for example, for a fraction, the image will be smaller than the original. So as you can see here, the original triangle ABC, let's go that way, the image is actually bigger. So if the scale factor is greater than 1, then the image will be larger, which would be the case above. Right? If the scale factor equals 1, then the image is congruent. It's the same shape as the original. So we use these two symbols. I dare say you might see the first more than the second, but those symbols are similar, used to describe similarity. So we can write ABCD is similar to EFGH, and the letters are written down in matching order. So D matches H, looking at this. So sometimes this the image will be given in some kind of transformation where it's a reflection, where it's rotated. But so we still have to think and match up. D and H to go to A and E go together. So we can then find our scale factor by, let me just erase that. Let's go from E to F, so that's the image, and that's 10, compared to A to B, gives us 10 to 5, or 2. Assuming, which we will, that the two given shapes are similar. So that's our scale factor, and as you can see, we said a number greater than 1, the image will be larger. So from original to image, we get a larger shape. Now this is a little bit crazy, but here's what we're going to do. We're going to do a scale factor of 1 to 2, and then a scale factor of 3. So knowing that we're less than 1, let's see if we are between 0 and 1, we're going to get a smaller shape. So what's going to happen here is I am going to zoom in just a little bit more. Okay, and so copy the given diagram. And what we're going to do is use the center of enlargement, which is O, and find out the scale factors to enlarge or to produce a similar triangle with the scale factor given. And this one is 1/2. So I'm going to try my very darndest to line up and draw a line with a ruler and connect each of these points to the center of enlargement. Here, at the halfway point is where I'm going to put my C prime. About there, there's my B prime. So now you'll be doing your very best to just sort of eyeball it and wing it. Unless you've got really handy-dandy measurements that can be split in half, but there you go. So my image now, each of these corresponding sides, let's say CB, will be twice as much as C prime B prime. And that's what it looks like when you have a fraction as your scale factor. We'll get a scale factor of 3. So as you might imagine, our image is going to be larger because we're larger than 1. So I'm going to do my very bestest to make a straight line from O through C and past C. I'm going to do the same thing from O to B and from our center of enlargement. Oopsies, line them up with a ruler. Ba-ba-boosh. For this exercise, I'm a little bit eyeballing it. But if it's a scale factor of 3, O to C, I'm going to treble that length and put it way out there. Whatever that length is from O to B, about there-ish, And from O to A gives us A prime. Oh, I didn't label that B prime. And so if our scale factor, it doesn't matter which way it's going, is larger than 1, then our image is going to end up being larger than our original. This one happens to just go in this direction. These figures are similar, so we know that for a start. Find the scale factor. Okay, so the scale factor, we want to find two sides that relate to each other. So the image is 6. So we're going to look at our scale factor is image over original. So I'm going to say that these two sides, and you can see if we spun them around, these are the two sides I'm choosing because if you look, they both give us numbers. So the image size is 6, and the original size is 4. So that gives us 6 over 4. That's 1.5, isn't it? 1.5 or 1.5. So going from our original to our image is times 1.5. So what do we got here? For B, we want to find the value of x. And I'm going to say that x matches up with the side 3 if I were to spin it around. Okay? So x is going to be equal to the original size 3 times 1.5, right? Because we're going from original to the image. So then, therefore, x will be equal to 4.5. Yes, it is. And now I'm going to just jump over here for C. Y, now y is this one here, and now we're a little bit different. So y, if I were to spin this puppy around, I would find that y corresponds to that puppy. So y is going to be equal to 7.5, but because we're going from image to original, we're going to divide that by 1.5 because we're going the other way around. So y is going to be equal to 5. There she blows.